So we'll say fluid. So when we say ideal fluid, so we'll do say like a ideal fluid. So what do you mean by ideal fluid? First of all, it should be non-viscous. Okay, fine. It should be non-viscous. Should be incompressible, rotational, non-viscous, incompressible, irrotational, and no surface tension effect. These are the primary things what will assume that one. Non-viscous means no viscous drag. Incompressible means the density will not change. That one. Irrotation means there won't be any rotation. So when I think water flowing, you can see some sort of like the water start swirling around a point. Am I right? Swirling like this if it is flowing. So somewhere at this particular point, it will rotate, no? So such a rotation should not occur. That's what I mean ideal fluid. So in all our discussion, when I say ideal, no, so all this will come into picture. So that's why in the book, so what happened, we just put ideal fluid. So it is understood that all these are is what we are assuming here. So we'll discuss some sort of like a ideal fluid. Then first one called like a streamline flow. So in streamline flow, if you take the various particles, this one, so here we'll put like this. Now, what are these arrows? This will be the direction of motion of the particles. There's the one thing. Next, again, what is the condition for streamline flow? One more important. So there's a point P I picked up, and there are three particles I'll pick up. So there's a particle A, B, C. Then any particle that passes through point B must have a same speed and the direction. Suppose like a velocity at point P should be how much? 10 meter per second. Now when particle C first passes, what should be the velocity of particle when it passes through point P? Must have the velocity 10 meter per second and should have same direction. Then B also. See, here A and B can have different speed, but when they're passing through a point, all the particles that are passing through a point must have same speed and direction. Then that is called like a streamline flow. So all the, so if the three particles A, B, and C possess same speed and direction, when they pass through given point, the flow is said to be streamline. This is one basic condition. Huh? Any particle that passes through a point must have a same speed. They can have different speed here, but if they pass through a point, they must have a same speed. There's a meaning of streamline flow here. Okay, now later we'll define streamline flow by another definition. So time being in fluid dynamics, we'll define. In viscosity, I'll bring another definition here. Now, what do you mean by turbulent? They're moving. The net flow is towards right. But what will happen? Different particles, when they arrive at a point, will have different speed. If the three particles possesses different speed, and direction, when they pass to a given point, the flow is said to be turbulent flow. Okay, no, so there's one basic definition like this, what we discuss. Now, turbulent flow is not there for syllabus, just have an idea. What all we discuss will be only a streamline flow. Okay, fine. So what all we discuss will be only a streamline flow here. Means like if all particles will have same speed, as it's also a streamline flow. So now, if all points, if all the particles of the fluid, if they're moving with the same speed and direction, then it is a streamline flow. But there's a primary definition. What it says: any particle passes through point P must have the same speed and direction. Then it's said to be streamline flow. There's a basic method. It can happen that all the particles here, they'll be moving with the same speed and same direction. Then it's streamline flow. So at a given point P, if three particles A and B passes with is needed, no?